Okay, in this video we're going to start graphing parabolas and exploring simple things we can do to these graphs. So the simplest parabola has equation y equals x squared, and to get a feel for what it looks like, we should plot a few points. So we have, of course, 0 square being 0, which means it passes through the origin, so right in the middle at that yellow dot there. Then if we go to x equals 1, we have 1 square being 1, so that means there's another point there up by 1. Then for x equals 2, squaring 2 gives you 4, so that sends us 4 units up to there. And then for x equals 3, squaring 3 gives you 9, so that puts us all the way up to there. And so you can see it's getting increasingly steep. But another interesting thing about squaring is that squaring a negative number gives you a positive answer as well. So that gives us a symmetry, where the negative numbers will square to the same positive values on the left side as well. And so putting all that together, we get a curve that looks something like this. And that is our most simple parabola. Okay, so what can we do to this guy? Well, say we now put a plus 3 at the end there. What impact would that have? Well, the equation happens to start with y equals, and that's super important, because it tells us the meaning of adding 3. We are increasing all the y values by 3, because that's what we have control of in our equation. And so that means every point on our parabola needs to get boosted up by 3, and that will move the entire parabola up by 3, sending it all the way up to there. What if we change it to minus 4? Well, for the same reason, we'd be moving the original parabola down by 4, so it would look like this instead. And when our parabola starts moving, it's often easiest to keep track of where the tip of it is. We call this point the vertex. So if we were drawing this for real by hand, we'd think of the vertex having moved down by 4, then we'd just draw the sort of smiley face coming from that point. Okay, so what else can we do with this parabola? We can do something like this. Now be very, very careful with what's happened here. Or rather, what hasn't happened. Notice the equation still looks like y equals something squared. What that tells us is that this yellow parabola hasn't changed at all. Okay, it's still y equals something squared, so the parabola hasn't been impacted in any way. Then what has happened? Well, x has changed into x plus 2. And when we change the whole meaning of x itself, the effect of that isn't to move the parabola. Again, nothing's happened to it, but it moves the entire universe the parabola lives in. And so that means to move the axis right by 2. And so it looks something a bit like this. But see how, because the whole world has gone right by 2, and the parabola hasn't moved, it looks as though the parabola has gone left by 2. And so that's why practically we will often see and remember this as going left by 2. But we gotta be clear, that's why it seems to go in reverse, plus is going left, because if we're changing what x means or what y means, the effect is to move the world behind the graph, not the graph itself. Notice we're not adding 2 to the x values. That's obvious because our equation doesn't explicitly say x equals something. We have no direct control over what x equals. Okay, so we're changing x into x plus 2, and so when you see that there's a change like that, you know the world is moving, the axis is moving, not the graph itself. Okay, so what if we change to x minus 3? Well, then that means the axis would go 3 to the left of its original position. So again, the parabola would appear to have gone right by 3. And that's how we'd think about it, even though deep in our hearts we know it actually is the world behind it moving, not the parabola itself. Okay, so moving on, what else can we do? We can say put a 2 in front, so multiply everything by 2. That means if we take all these y values here, remember we're controlling the y values, they would all have to shoot up to double their original height. A really important difference here though is that doubling 0 is still 0, so the vertex stays put. It's still going to be at the origin if this is all we are doing to the graph. So that makes the parabola go narrower because every point has to shoot higher. Okay, So let's reset this, and this time we'll put a half in front. So now every y value gets squished to half its original height, and the parabola goes out wider like that. So these multiplications can either make it narrower or wider depending on whether the number we're multiplying by is bigger than 1 or smaller than 1, okay? But finally, if we were to multiply by a negative there, then all the upward pointing y values have to now flip to point down, and we end up with a sad face. So that's what happens if the x square is negative, it turns upside down into a sad face. And that's all we're going to do with these parabolas for starters. It's the simplest thing we're going to do with them, but in some ways it's the most important, because these actions can actually be done to pretty much any curve, not just parabolas, in exactly the same way, and it will produce the same results, so the movements and the stretching and all that stuff. So it's super important you understand these ways of changing the parabola, or the world behind it, or whatever, because it'll apply to other graphs as well. So let's summarize and make a screen you can sort of copy down if you like. We started with an axis and the most basic parabola y equals x squared. Adding a number at the end there had the effect of moving the parabola up. Or down if k is negative, of course. Then changing x into something else, like x plus something, had the effect of moving not the parabola, but the world it lives in, so the whole axis would shove to the right by h. But this appears to make the parabola go left by h. So that's the two things that can happen. Adding a number at the end gives a boost to all the y values, so it moves it up or down, depending on whether k is positive or negative. Then changing x into something else, like x plus h, will move the axis right by h, and therefore the parabola will look like it's gone left by h. Again, with directions reversed, if h is negative. So then the vertex of the parabola has now moved to coordinates negative hk. Okay, and that's how we deal with the movement of a parabola, or any other graph. The other thing we did revolved around multiplication. So starting with the basic parabola y equals x squared again, multiplying by the number a out the front had the effect of stretching it to make it either narrower or wider. If the number a is bigger than 1, it makes it narrower because all the y values have to get bigger. So they might double or triple or something, and that makes the whole thing go narrow. If the number a is smaller than 1, makes it go wider because all the y values have to get smaller. So they shrink by a half or a quarter or something, and the whole thing gets wider. And finally, if this number a happens to be a negative, that will flip the whole parabola upside down to be a sad face. And so we get something that looks like this. And that's all we're going to do with parabolas for now, so this might be a good place to stop and pause and write, and that's all for now, so see you around.